This video provides an introduction to kernel calculations on rasters using the Raster Calculator tool. It expands on a previous video where we introduced the Raster Calculator tool for performing simple single-cell calculations, and we did this by determining the topographic position index for a given input terrain. This video looks at how we could perform the same calculation but using a single Raster Calculator function and the kernel data type. If you haven't seen the previous introductory video, please do so, as we're not going to cover the basics of raster calculation in this particular video. Let's familiarize ourselves first with the input dataset and the determination of topographic position index. So topographic position index, or TPI, is calculated using spatially localized statistics, and we take the mean of a local kernel minus the minimum value in that kernel divided by the max minus the min value, or the range. So the terrain dataset we used is my favorite terrain dataset, the mound with the pimples or pot marks and the outcropping rocky areas on the slope, the downward slope of the mound. Let's open the raster calculator now and have a look at declaring rasters. So I'm going to add a raster variable here, and I'm going to set the input to that raster variable to be the dataset that we have up here in the background. I'm also going to define this as a kernel data type. So previously we looked at simple calculations, which uses the floating point value of a single cell. This time we're going to use a neighborhood, or a kernel, and we're going to use a 9x9 kernel. Let's familiarize ourselves first with what a kernel is, particularly in the context of the raster calculator. So in my graphic I have an input raster dataset here, and I have a kernel here. You will see that the kernel is essentially a matrix, and this is a 3x3 kernel, and the values in the kernel are referenced relative to a central cell, or a central kernel cell, which has a 0, 0 coordinate reference. Anything to the left, up, down, or right of the central cell has an associated row and column reference. So this is row 0, column -1. This is row -1, column -1, for instance. So that's how kernel items are addressed. Now, unlike the kernel processor, the scalar or the multiplier values, or the factors, for each of the kernel items is defaulted to 1 in the raster calculator. So this kernel is taken and placed over the input raster, and the kernel is moved along the columns and down the rows over the entire data set. The kernel value at the center of the raster is determined based on the sum of all the values here divided by the number of items in the kernel. So in this case, that value is 4.55. So that is what's called the kernel value. Let's go back now to the raster calculator and have a look at how we use a kernel in that tool. So you will notice that since I have declared this raster variable, that variable now exists as an argument to my calculate function. I'm going to rename this Bathy, and again my argument to the calculate function has also changed. So now this particular kernel applied to this particular raster dataset is called Bathy as far as the calculator function is concerned. You will also notice that as I've selected Bathy here, it has now made a series of kernel properties available to me. Now these are the properties of the underlying kernel objects from the RAMP programming interface. So you can go to the API documentation and have a look at all of those properties and methods and what they do. Let's quickly do that now. So if I go to Development, API Reference, and I click on the kernel object, it describes it and it provides all of the properties, methods and functions with descriptions for the kernel object. The same is true for the kernel item object, which is a child object of the kernel. It's the individual kernel item within there. And again, you can see the properties for those particular methods. So back in the raster calculator, it makes some of these available for you to use in the calculator function. The most common ones are listed at the top here before this little dash delimiter. So the kernel value is essentially the mean of all the valid items, cell values in the kernel. The minimum value is the minimum value counted in the kernel, and the max is the maximum value. This is the nearest neighbor value, so at the center of the kernel, or the kernel reference 00, this is the nearest neighboring value for the input raster cell. And this is the inverse distance weighted value, also at the center of the kernel. Null raster value returns the underlying null value from the input raster. The sum of raster values is simply the sum of all the valid values that are in the kernel. Usable items is a count for the number of kernel items within the kernel that actually contain valid or non-null raster values. And then you can address a specific item within the kernel using a row column reference or indeed its index reference. We'll come back to that a little bit later. What we want to do though is look at how we can implement the topographic position index function in the raster calculator. So I'm going to update this, calculate TPI and the date, author, and we're going to say, I'm going to add a comment, TPI equals mean minus min divided by max minus min. Okay. So let's declare a float called TPI. And simply what we can do now is we can take let's do this. Let's calculate the mean. And the mean is going to simply be the kernel value. So if I position my cursor here and double click, you'll see that it's returned bathy.kernel value. I'm going to also calculate my max, and that is simply bathy.max raster value. And I'm going to also calculate the min, and that is bathy.min raster value from my 9x9 kernel. So now let's calculate TPI, which is the mean minus the min divided by the max minus the min. And then let's return the TPI. Done. Let's run this function and see what it does. And we render it. And just like we used in the raster calculator in the previous video, this is the same result. I mentioned that you could also directly access an individual kernel item within the raster calculator. So let's start up a new raster calculator and let's explore how we might do that. So I'm going to again add a raster variable which will be my terrain data set. I'm going to declare it as a kernel, and I'm going to use a 3x3 kernel in this case. And we're going to take the mean of the upper right and lower left kernel items. So that means that I have to address in my 3x3 kernel the upper right and lower left item. So in this case, the upper right will be here, and the lower left will be here. So that is -1 +1 and +1 -1 kernel items. And we're going to take the mean of these two values within the kernel. Okay, so let's first get the upper right. Okay, float UR equals. So I'm going to rename my raster variable Bathy, and this time I'm going to get the specific item within that kernel object, and I'm going to get the value at that particular thing. So now you'll notice that when I select something that returns a kernel item, I now have the kernel item properties available to me here. So I'm going to add that in here. Okay. And my row and column I'm going to make, so it's row -1, column 1. Yep. And similarly, my lower left is going to be row 1, column -1. And I'm going to calculate the mean, which will equal the upper right plus the lower left divided by 2. And let's return that. Okay, let's run this now and see what happens. We need to clip this because there are values on the edges where the kernel included the null values, and it was using null values in that calculation. So that's a little bit wrong. So we need to clip it and then look at it again. So let's just clip a section of it out and render that, and those null values should now be gone. And this is the result. There's a little bit more directionality now to the data set because it's biased towards the lower left and upper right directions, and it's returning the mean of those. Let's make our function a little bit smarter to try and deal with the null values that we're creeping in and trying to exclude those from the function. Okay, so let's just say if upper right equals, and then we're going to take the null value. So if the upper right equals the Bathy no raster value, or the lower left equals the Bathy no value, no null value, then return a null value. Otherwise, perform this calculation. Okay, let's run this now and see what happens. And when we render it, you'll notice that it no longer has those null values on the outsides. Let's look at one more example. So in this case, I've gone ahead and written the code already, but this is going to calculate the mean of the kernel in a brute force way. You could obviously always return the kernel value and that would always give you the mean. However, this is an example of how you might cycle through each of the kernel items and do some sort of evaluation. So I have I, which is a loop counter. I have usable, which is an integer that is going to count the number of usable items kernel items within the kernel, and then I'm going to sum the value of the usable items. So I set up a for loop. So from I to the kernel count property, that's the number of kernel items that are within the Bathy kernel, and I increment. So this is going to loop through each of the kernel items within the Bathy kernel. I then get the value of the the raster value at the specific kernel item within the kernel. So here I get bathy.item_i.raster value, and then I do some logic checking. So if the value is not equal to the kernel's null raster value, then add to the sum and increment the usable count. And at the end of this loop, return the sum divided by the usable. So that's an example of how you can use some of the other properties and methods within the kernel and kernel item objects in the ramp calculator. So this has been an introduction to using kernels within the raster calculator. I hope the video has been useful to you, and thanks for watching.